Sara Petersson is a patent information specialist here at Uppsala Innovation. Her PhD in Swedish University of Agricultural Sciences and her postdoctoral studies in Umeå Plant Science Center have given her a solid background in plant biotech and agriculture. Sara Petersson, the stage is yours.
Thank you. I will share my screen. Hi, everybody. So as we heard, I have a background in agriculture and plant science. I worked for a couple of years at the Swedish Patent and Administration Office before I started working at the Uppsala University Innovation Office. Today I was asked to talk about intellectual property in agriculture, but I thought that before we start talking about intellectual property, see if I can. We'll start talking about intellectual assets, because that's where we need to start. Intellectual assets in agriculture. So imagine that you're a small startup company or a research group or a seed company or some food tech company. You have assets, you have financial assets, and that's the money you have, either your research money or your the money you have in the company. You can have tangible assets, and that could be, for example, the machines you have if you're a farmer, instruments, lab equipment. And then you have the intangible assets, and those are the interesting ones today. It's human, for example, that's your staff. Relational could be customers or suppliers, people like this. And then you have the intellectual assets, and they are the really interesting ones. Inventions, data sets, models, methods, stuff like that. And why are these interesting for you? Because some of them, they can be protected. And if you have many assets in your group or in your company, you could say that in some instances, maybe up to 80% of a company's worth or value nowadays could be intangible assets, meaning intellectual assets. But in what way does this relate to you as students in your role as researchers or becoming researchers, maybe pursuing a PhD in the future? Why should you protect your ideas and inventions as a researcher? Why not just publish it and leave it open to society so everyone can take part of your discoveries and develop products and services based on this? Well, if you want to really create impact in society, you need to protect your ideas. And why do you need to do that? And that's because researchers, they are not CEOs of companies. They are not salespersons or marketing specialists. They need help. You need help in the future. You have the ideas and you have the technical knowledge, but you need someone to come in and invest in your idea, and especially invest in your team, because it's really important to have a good team around the idea if you want to get investments. So protecting your idea is one way of attracting finance from venture capitalists, for example, because they really like to get some sort of return on their investments. And if they spend a lot of time and money developing a product or a service, and then someone else just swoops in at the end and takes the idea and the product and sells it for half the price, they will never get any return on their investment. So that's why you need to protect. So the idea behind the IP system is actually to encourage scientific development and technological development, because it's sort of a deal between the researcher or the inventor and the state. So you get monopoly of your idea for a period of time, and in return you have to disclose your idea in such a detail that someone else can come in and sort of say, I could continue working on this and maybe develop the idea further. And that's sort of the idea that the day the patent expires, someone else have developed your idea and made an improved or better version, and it will be available on the market maybe the day after. It's like this, especially in the pharmaceutical industry. You have the generic drugs available basically the same day that the patent expires. So it will create incentives for utilizing the research, because in the end, it all comes down to, can we make money out of this? Some ideas that are just given to society, they may not ever turn out into anything that could be really put into use. And you can also control how your idea is used if you have a patent, because then you can control the use of it. I will just briefly mention the four most common forms of IP rights. So we have trademarks and patents. I will come back to them. And then design, which is probably, if you think about clothes and furniture and patterns on fabrics and wallpapers, that's where you get design protection, watches maybe. And then you have copyright. That's for music and books and films and software, if you didn't know maybe. So computer software is protected by copyright. But I thought that we should start with trademark, which is a way to protect your intellectual assets. So an intellectual asset is sort of something in the mind. It's not a physical thing. It's ideas and know-how. And trademarks are used for products and services. So for example, Nike or Puma, you get shoes, and you can have service. It could be Spotify or Google. They give you a music service and a search service. Trademarks are restricted in geography and sector, so you can register your trademark only in Europe maybe, and only in agriculture, for example. And it could be unlimited in time. And this is a really valuable business strategic tool because it's quite cheap and easy to obtain. And if you don't have a patent, for example, maybe a really strong trademark could be worth more, because trademarks could basically last forever, but patents will only last for 20 years. So don't forget trademarks. If you're starting a company, think about the trademark. Think about how do I want to be perceived in my sector of research and products. So I have some examples here of trademarks you might be familiar with. So the ones on the left are basically trademarks on seed companies, crop science, John Deere's for tractors and the agriculture equipment. So these are sort of the producers, agriculture producers before it hits the market. And then the middle sector, you have apples, bananas, pasta, and butter. So these are just products that are not processed, well, pasta and butter processed, but not in the way that Mark was talking about, at least. And they are also important trademarks. And then on the right, we have these novel foods, where you have meat alternatives and alternatives to cheese and milk. Maybe you're not familiar with all of them because they're Swedish brands, but they are really working on keeping their brands interesting. And many of these companies also have patents, but sometimes the patents are maybe not that important for sales. It's the brand, the trademark, that's really important. There's something else which is not really a trademark, but it's also intellectual asset, and that could be a GI, geographical indication. You've probably seen it on some products. It just indicates that the product is from a special area, for example, champagne or feta cheese. You can't call feta cheese if it's not made in Greece, then it's usually called salad cheese or something else. Parma ham, it's only ham when it's produced somewhere else. So this could give your product also an extra sort of value. And maybe this is not really interesting when you are working with novel foods and novel products like you are. But this is also an important part of the intellectual property palette that you have available in agriculture. Let's see if I think I'm just trying to switch, but no, okay, sorry, I have to go. Okay, let's go back to patents. So patents, that's what you really wanted to hear about today, I guess. It's for technical solutions. And they're restricted in time and geography, so there are no world patents. You apply for a patent in the country where you think you have your market. So usually people apply in Europe, US, Australia, China, Japan, South Korea. And then the rest of the world, well, maybe some countries, but these are the countries or the areas where you have the highest risk of infringement, meaning that someone will sort of steal your idea. And the patent will give you the right to stop others from producing or selling or importing the product. But this is also, you should also always remember that this is a business strategic tool. Make sure that if you decide to patent something, it's the right decision for your business, that the cost of the patent will actually be, you can have a revenue of the product that will sort of equal out this cost. So don't just apply for patents for having one. It could be sort of a bargaining chip if you are collaborating with someone, but remember, it's a business strategic tool and it's expensive and it takes quite a lot of time to get. However, it's a really good source of information. So if you are used to looking at databases of scientific literature, I think you should also look into the patent databases. If you're new to this, use Google Patents. Everyone can Google, and just write in your favorite keywords and see what pops up. Because companies, they don't publish papers. They publish patent documents, and they are sort of like scientific papers, but they are more detailed, and they're always focused on sort of technical details. So the backstory is kind of thin sometimes, but this is a fantastic place to get good information for you as students. So what can you patent? Here are some examples of innovation in agriculture. Like Mark told us about, meat that you produce in novel ways. The LED lights, when they are nowadays, when it's possible to produce them cheap and in large numbers, LED lighting is really important in managing the light regimes in greenhouses. Equipment for hydroponic, aeroponic, that could be protected with a lot of patents. Drone surveillance of crops is quite common, looking at the status of plant health, nutrition, and water. Tissue culturing methods could be protected. And then one of the favorites, it's a scarecrow, bottom right here, with a green light that scares off the crows with the light. So these are some examples. So what is possible to patent? There are 3 requirements. It needs to be industrially applicable, it needs to be novel, and it should be inventive. And the industrial applicability is not that difficult to understand. It should just have a technical effect, it should be a technical solution to a problem. The novelty, that's something that's really important for you as scientists to understand. Because if you publish something, it will be seen as prior art when you apply for a patent. So a patent can only be granted if what you are trying to protect has never been shown or described by anybody at any point, any language, any time, any source. So that means if you at some point described your invention at some conference you went to, you had a really nice poster, it ended up in the abstract book, and the patent office will find it and say, this is not novel, this was presented last year. So this is something to keep in mind. I know you're presenting all your products. I don't know what the competition, the iGEM competition have, if they have an IP policy, but it's important to remember that if you think you have something worth protecting, you need to send in a patent application before you share this information with society, because then it will not be novel anymore. And then, of course, it should be inventive. And what's inventive? Well, it shouldn't be obvious for someone who is skilled, the skilled person, that someone basically like you, who knows the same things that you know, but they're not very inventive, the skilled person. But basically, you shouldn't be able to put one and one together and it equals 2. But if you put 1 and 1 together and you get 5, that's really inventive. So that's always a discussion with the patent office if it's inventive or not. But the novelty requirement, keep that in the back of your mind always when you are presenting your ideas. There are some things that can't be patented, discoveries, for example. So if you discover a new strain of bacteria that is really important in some application, you cannot patent the bacteria. You can patent an application where you use this strain. That's different. And then you can't patent things that are contrary to public policy or morality. And there is one example that I always bring up, and it's the cloning of human embryos. You can't, of course, patent computer programs because they were copyright protected. Methods of treating the human body can't be protected either. And then you have plant and animal varieties, and that could be interesting for you because you're all in the field of working with plants and animal cells right now, I guess. And they can't be patented. And essentially biological processes, and that means that if you if you cross one flower with another flower, even though it's very technical the way you do it, it's essentially a biological process, and then it can be patented. So there are a lot of exceptions, but if you need, at some point need help, someone will help you and explain to you if it's possible or not. GMOs. I was asked to say a few words about GMOs, and genetically modified organisms. And as Mark said, it's not really accepted in Europe. They can, of course, still be patented. So what you patent, it's not actually the genetically modified organism, but the trait that this organism sort of harbors. So it's not the organism itself. So examples of traits that can be patented are resistance to potato blight, for example, or Roundup Ready soybeans, or different fermentation processes. You can have animals, breeds that are all of a sudden, you can induce diabetes when they're 3 months old, so you can use them in research. So these are examples of genetically GMOs that you can protect. But of course, it's not the soybean or the mouse or the potato, it's the ability they have. And that could probably transfer to some other crop than potato or some other animal. Plants, as I said, can't be protected with patents, but then we have the plant variety protection, which is a complementary IP system for plant breeders. And this is important because it takes up to 10 years, more or less, to produce a new variety of some crop. So it's a lot of work. Basically, it's the same amount of time it takes to produce a new drug. So they need to be protected somehow. They need to be new, and that means that they have not been commercialized before, and they should be different from other varieties. Uniform and stable. So there are some requirements to get the plant variety protection. And this is the plant breeding community are really happy with this system, and they don't want plants to be protected with patents. So it's a very well functioning system. But as I said in the beginning, if you want to really make an impact, you need to, of course, publish papers, because this will help your academic career, where you can come up with new ideas, new solutions to problems. But you also need to patent because it's difficult to do this on your own. You need help. You need a good team and a good scientific team, and then you need a good business team. So remember to do it in the right order. So you patent first, and then you publish. So you don't hinder yourself from getting your patent accepted. And as I said, remember the absolute requirement for novelty. Don't speculate in your articles that, oh, this is a really interesting finding. Maybe it could be used in this and this way in the future, because then basically you have already told the world about the idea. Maybe you don't have the technical solution yet, but in the future it will be obvious that, well, if you have technical knowledge and you know that it could be used this way, they will say, well, it's obvious. So don't speculate in your papers. It's always fun to do that, but try not to do that. And it's of course not something you put on your resume, even though it might look good. It's too expensive. If you want to apply for a PhD or postdoc in the future, it's probably better to have a high-ranking paper than a failed patent application. So don't do it for the sake of your resume. Think about the business strategy before you decide to file something. And if you need help in the future with this, always remember this is not something you need to do on your own. You need to get help. Here in Uppsala, we have the innovation office. In most other countries, they have a tech transfer office. So there's usually someone you can ask. And if you're in the Netherlands, I realize there are a lot of connections here to the Netherlands, and that's really a hotspot for food tech and ag tech startup companies. So if you want to go somewhere for a sabbatical, a year, like a semester abroad, go to any of these places if you're interested in this field of research. Yeah, so if you have any questions, I'm up for that.
Thank you so much, Sara, for such an interesting presentation. Please, anyone, if you have questions, raise your hand or write in the chat. Okay, so some questions from the chat. Hi, Sara. You mentioned that the patent office can be a great source of inspiration. However, how do you make sure that your product does not too closely resemble the patented product? And how do you make sure that your idea is not already patented?
Very good question, because if you have a really high-tech product, you don't know, is it already patented? If your product will be successful in the market, you will know, because they will probably contact you and say, this is already protected. Please cease with what you're doing and stop the use of this product. But I would recommend you to actually use the different patent databases and search. Do searches, always do searches. Use Google Patent, ESPASnet, the European Patent Office has a fantastic database that you can use. I just learned about a database called lens.org today, which seems it's free and easy to use. It seems quite user-friendly. So just go out there and search and see what's out there. And if your product becomes successful, you need professional help because then you need to go in maybe deeper into what's out there. Do some initial searches.
Another question from the chat. Can you give the price range of patent application? Let's say, for example, in Europe.
So usually you start with a national priority application, and that's, I don't know, 10,000 euros maybe. That's what it would cost in Sweden. And then it's a bit more, maybe if you want a European application, maybe it's 15,000. So it's not expensive to actually file the application, but what is expensive is to find a good patent attorney to write the application for you, because you should not write it yourself. You can provide them with the data and the background information, but you need to make sure you find a good patent attorney who understands your field of research, who understands the idea well. So if you want quality, it will cost you. So that's of course again why you need the initial sort of startup money to get the initial application. But in the future, you might have patents in 10 different countries. That means 10 different filing fees, and then you pay yearly fees. So make sure the patent is worth the revenue you think you will have. So you don't spend all this money and then, well, it didn't work out. We had something more interesting to do. But do an initial filing. I would recommend that. That's expensive, but just sort of to mark your spot that this idea is mine, and then you have a year where you can go out and find venture capital or other capital.
So we have another question from the chat. What happens if we apply for a patent and the time passes without a team producing any good results? Can someone get an extension from the patent application?
No, so you don't get extensions. So during the first year, you file your priority application, and during this year, you can add more data to the application. You can't sort of add inventions, but you can add data to back up the statement. And if you don't have anything better after a year, you can just decide, should I withdraw the application? You can do that, and then it will never be published. Otherwise, it will be published after 18 months, and then it's not a patent, but the whole idea is out there. So it could be a good idea to sort of withdraw the application before it becomes public. If you want to continue working on this, and if you don't, if you think this information could be interesting for someone else, you can just let it go and let it be published in the future. But there are no patents or various like deadline. You need, so the day you file the application, that's where it sort of the clock starts ticking, and from that day you have 20 years of protection if it's granted, and that's retroactive. So if sometimes it takes a couple of years before you get it granted, but it's retroactive.
And one last question. Since most of the people here are people who are participating in iGEM, when does a team qualify to apply for a patent?
I think they qualify when they have an idea that they think is worth protecting. So patents are for early ideas. You don't need the same amount of data to back up your claims as you would do in a scientific paper. And that's sort of the idea, that you should be able to protect it early. And then of course you have this year to add more data. But as soon as they think they have something that could be worth protecting, they should first keep quiet, don't talk about it, don't publish, get some help from a TTO or some innovation office, and then search for the idea and see if it's already out there. And if they find something very similar, well, then it's sort of a question, is it different enough for it to be granted? And that's always difficult, but as soon as possible and with the help of someone else.
Thank you so much, Sara. Unfortunately, we do not have time for any more questions as we need to proceed with the schedule.
Thank you, Sara.